Welcome to the DIY Honda Garage channel. This presentation details the diagnostic steps for DTC P0339, indicating a CKP sensor circuit intermittent interruption on Honda Civic models from 2016 to 2021. DTC stands for Diagnostic Trouble Code, which is a specific code used by the engine control unit to identify issues. The CKP sensor refers to the Crankshaft Position sensor, pivotal for the engine management system. It allows for accurate engine timing by providing the position of the crankshaft to the powertrain control module, PCM, for optimal fuel injection and ignition timing. When this sensor malfunctions or experiences an intermittent issue, it can disrupt the entire engine operation, leading to poor performance and erratic behavior while driving. Understanding the symptoms and troubleshooting steps for P0339 is critical for resolving the underlying issue effectively. DTC P0339 indicates an intermittent interruption in the crankshaft position, CKP, sensor circuit. The CKP sensor plays a crucial role in determining the precise position of the crankshaft, which is necessary for the engine's timing and operation. Located on the engine block, it sends data to the powertrain control module, PCM, to assist in controlling various engine functions. This sensor's data is vital for fuel injection timing and ignition timing, which are essential for optimal engine performance. An intermittent circuit issue means that the connection might be faulty, leading to inconsistent readings or failure to relay information entirely, which can cause significant issues when driving. Accurate verification of this sensor's operation is paramount in diagnosing engine performance problems. The DTC P0339 may arise from several underlying causes. A faulty crankshaft position, CKP, sensor can lead to inaccurate data transmission, disrupting the engine's timing. If the sensor is damaged or malfunctioning, it can send intermittent signals to the PCM. Another potential cause could be a malfunction within the powertrain control module, PCM, itself, which might not process data effectively, resulting in erratic engine behavior. Additionally, wiring issues, such as frayed or damaged wires, can cause intermittent interruptions, leading to the DTC being triggered. Poor connections or loose terminals at either the CKP sensor or PCM can further complicate the situation, emphasizing the need for careful checks and, if necessary, repairs. Identifying these causes is essential for addressing the P0339 code effectively. The symptoms associated with DTC P0339 can significantly affect driving dynamics. An engine may stall or hesitate during operation due to the lack of accurate position data supplied by the CKP sensor. This can lead to irregular power delivery, where the car experiences sudden loss of acceleration or power. Drivers may notice dashboard warning lights illuminating, which are indicative of engine issues. In some cases, the vehicle may run normally at idle, but could have performance problems at higher speeds. These symptoms highlight the importance of diagnosing and correcting issues related to the crankshaft position sensor, as they can affect overall safety and drivability. Paying attention to these signs can help prevent more severe issues from developing, making early diagnosis critical. In the first troubleshooting step for DTC P0339, begin by turning the vehicle's ignition to the on mode, which powers the vehicle's electronic systems without starting the engine. Next, utilize the Honda Diagnostic System, HDS, to clear any existing diagnostic trouble codes. This allows the system to reset and helps in obtaining accurate readings during the next engine startup. After clearing the DTC, start the engine and allow it to idle for approximately 10 seconds. This period is essential, as it enables the systems to stabilize, and the vehicle can then be monitored for any immediate issues. After idling, check the OBD onboard diagnostic status for DTC P0339 through the HDS interface. Based on the HDS's response, failed, passed, or not completed, you will proceed to the next appropriate step in the troubleshooting process. This verification establishes if the failure persists. Step 2 involves performing a test drive of the vehicle for several minutes to gather more data about the CKP sensor's performance in dynamic conditions. During the test drive, it is essential to monitor specific parameters such as engine speed and vehicle speed, as recorded in the onboard snapshot parameters. This step helps to identify if the intermittent issue occurs during movement or at specific speeds. After driving, again check the OBD status through the HDS for DTC P0339. If the HDS indicates a failed status, it confirms the failure has been reproduced and you should proceed to the next step. However, if it shows passed, indicating that the intermittent failure hasn't occurred during this session, you can conclude that the system is currently functioning correctly. In this case, it's essential to inspect for poor connections at the CKP sensor or PCM, as intermittent issues can often stem from minor electric connection failures. Thus far in the troubleshooting process, the next significant step is checking the condition of the connectors and terminals related to the CKP sensor circuit. Begin by turning the vehicle to the off-lock mode to ensure safety during inspection. Check for poor connections or loose terminals at the CKP sensor, the powertrain control module, PCM, and throughout engine and body grounds. A poor connection can lead to signal interruptions, which in turn may trigger DTC P0339. If the connections and terminals are determined to be in good condition, you can advance to the next troubleshooting step. Conversely, if you detect any issues with the connections, it is vital to repair them to eliminate any fault sources before proceeding. Ensuring proper electrical continuity is crucial for the system to function optimally and for the CKP sensor to relay accurate information to the PCM. In the final troubleshooting step for DTC P0339, you will need to remove the Crankshaft Position CKP sensor from its mounted location on the engine block. This step is necessary to visually inspect the CKP pulse plate associated with the sensor. Check for any signs of damage on the pulse plate, which can lead to incorrect positioning data being sent to the powertrain control module, PCM. If the pulse plate is found to be damaged, replacing it is critical to ensure the proper functioning of the CKP sensor and, subsequently, the engine. On the other hand, if the pulse plate appears to be intact and undamaged, the next course of action would be to replace the CKP sensor itself. This is vital for restoring the proper operation of the crankshaft position sensor circuit and enhancing overall engine performance. After completing all repairs for the DTC P0339, it is essential to conduct a final verification of the repairs. This process begins with another test drive of the vehicle to observe any improvements and ensure the CKP sensor circuit is functioning as intended. During the test drive, you will want to closely monitor the vehicle's performance and operation, ensuring that there are no signs of engine stalling or irregular power delivery. After the drive, connect the Honda Diagnostic System, HDS, once more to check the status of any DTCs. It's crucial that the system confirms a clear DTC status, indicating that the issues related to the CKP sensor circuit have been resolved. Only after you have verified the DTC status can you conclude that the repairs are successful and the vehicle is ready for normal operation. Consistent follow-up checks are vital to ensure the reliability of the repairs as well. To minimize the chances of encountering DTC P0339 in the future, practicing preventive maintenance is key. Regular inspections of the CKP sensor and its associated wiring and connectors can help catch issues before they escalate. During routine maintenance, make it a point to check that all connections are secure and free from corrosion, as these are common reasons for intermittent failures. It's also beneficial to examine the CKP pulse plate periodically to ensure that it remains undamaged and well aligned. Additionally, following the manufacturer's recommended service schedule can greatly contribute to the overall longevity and reliability of the vehicle. By adopting these preventive measures, you can contribute to fewer disruptions in engine performance and enhance your Honda Civic's overall reliability. In summary, DTC P0339 represents a CKP sensor circuit intermittent interruption, a critical issue affecting engine performance in the Honda Civic 2016 to 2021 models. Understanding the role of the CKP sensor and the potential causes of failure is crucial for effective diagnostics. The systematic troubleshooting process, beginning with problem verification, moving through detailed checks, and concluding with repair verification, is essential for identifying and addressing the issue thoroughly. By taking necessary preventive measures and conducting regular maintenance, owners can reduce the likelihood of encountering this error down the line. This presentation underscores the importance of a clear and methodical approach to automotive diagnostics, ensuring that the vehicle operates reliably and efficiently. Please like and subscribe to the channel. See you next time!